Bash Arithmetic is the shell's built-in way to crunch numbers right from the command line. Meet your guide, a friendly blinking terminal ready to walk you through the rules. Rule 1. Bash does integer math only. No floats, no decimals, no fractions. When you divide 1 by 3, you don't get 0.33. You get 0, because the result truncates toward 0. Bash gives you 3 syntaxes to choose from. Double parentheses with a $, substitutes the result into your command. Plain double parentheses. Evaluate a true or false condition for tests and loops. And the let built-in assigns results directly to variables. Each has its lane. Use the right one for the job. The operator menu covers everything you need. Plus, minus, multiply, divide, modulo for remainders, double star for exponents, and pre- or post-increment and decrement for counters. Think of them as dishes served up by a bashful chef ready to plate your numbers. Bash Arithmetic runs on 64-bit signed integers, which means values can grow up to about 9 quintillion. Push past that ceiling, specifically past 2 to the 63rd, and the counter rolls over into negative territory. Shocking, but predictable once you know the boundary. Finally, a historical footnote, the expr command. It was the old-school way to do arithmetic in shells before Bash built in proper math support. It's clunky, external, and full of quoting headaches. We won't be using it. Rest in peace, expr. Welcome to a hands-on demo of Bash Arithmetic. We'll work through order of precedence, variable expansion, exponentiation, the let built-in for loop iteration, and the modulo operator, all from the command line, no scripts required. Every solid terminal session starts with a clean slate. The clear command wipes the viewport and drops you back at the prompt. Purely cosmetic, but a professional habit before running a new sequence of commands. Bash follows standard arithmetic precedence. Multiplication binds tighter than addition. The expression 2 plus 3 by 4 evaluates the multiplication first, giving 12, then adds 2 for a final result of 14. The syntax is Bash's built-in arithmetic expansion. Variables expand directly inside arithmetic contexts, so you can build expressions from named values. Here we assign x equals 10 and then square it, producing 100. Note there's no $sign on the left side of the assignment, but you do reference the variable with $x inside the arithmetic. The double asterisk operator is Bash's exponentiation. Raise the left operand to the power of the right. 2 to the 10th power is 1024, which is exactly why 1 KB equals 1024 bytes in computing. Arithmetic expansion handles large integers natively. The let built-in evaluates an arithmetic expression and assigns the result directly to a variable. No $sign needed, no echo required to confirm. We compute 5 plus 5 and store it in y, then print it to verify the value is 10. For loops let you iterate over a list of values and run a command for each one. Here we loop through 1, 2, and 3, printing each value on its own line. The variable I takes each item in turn, and the done block executes once per iteration. Finally, the modulo operator % returns the remainder after division. 17 divided by 5 gives 3 with a remainder of 2, so 17% 5 evaluates to 2. Modulo is essential for tasks like cycling through indices, detecting even and odd numbers, and time-based bucketing.